Okay, so it sounds like people can hear us.
Yes. Okay. People can hear us now.
People can see
Hello.
us. Hi.
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 So awkward. So we're super sorry that we're late. Yeah. Hi everyone. I'm Shirley. This is
Tony. Hi.
and welcome to the 14th apparently episode of ShirleyChats. Did not expect to get into the double digits.
It's good.
At all. Although
people seem to like it.
Yeah, I don't know why. And actually, if anybody's noticed, I just keep interviewing the same people over and over again.
That's funny.
Because
Matt just replied, perfect timing. I'm standing by for the show. Hi, Matt. How are you doing?
Yeah, I hope you're in here, Matt. So...
Wait, aren't we supposed to see their comments and stuff?
Yeah. So, but that's the chat. So, Matt, that one is... So, if anybody saw the picture of our setup, it's kind of a little bit intense, and this is why we're late, because, first of all, we needed to get... okay. Should we start with the story of how we failed completely?
Sure.
So, I like to think that Tony and I have a tradition of going to Boba Guys before we do this.
Mm-hmm.
And so we set up this chat for 11:30, and what neither of us realized or decided to check was Boba Guys doesn't open until noon on Sunday. Hey Andrew, hello. So we both failed really hard. So then we were like, okay, what's another alternative? So we went to, or rather, Tony and Stephanie went to Ritual, and my mocha took like 30 minutes. 25.
Yeah.
So
this is a Ritual coffee at Hayes Valley, like Octavia and Hayes. Really slow today.
Yeah, and then we hightailed it back here and got here at 11:25.
Yeah, that's what I was saying.
And then we decided that we needed this setup. I don't know. Yep.
Yeah,
so this is...
To our left is the screen that I used to use for coding. It's a vertical screen where I usually put the code. So my setup used to be computer for the actual screen, and then this giant vertical screen that basically is all the code, so I can actually see it. It's very effective.
Yeah, this is really cool. But yeah. Hey, this is Sam. Hey, Sam. Does that mean that Susie's also watching?
Probably. That's actually probably Susie.
Is it actually Susie?
That would be my guess. So I could prove us wrong.
Yeah, I don't know, but how would we know that it's not Susie? What can Sam say that makes us know that it's not Susie?
That's yuppers. See?
Ooh, hey Matt. Matt's joined the chat. Okay.
Okay, so what were we talking about today?
Okay, so we actually had an agenda for
Because I asked for one.
Yeah, because usually, as some people might know, usually I'm just we're gonna freestyle this. We'll just see what happens. But no, Tony needs more than that. So
Structure is very important.
So I believe what we were gonna talk today is we were gonna start with R2D3, Visual Introduction to Machine Learning. I actually looked up when this was published, and it was mid 2015. And if I don't know if anybody remembers, but last June or July, you and I did an interview. This was when I was still on Twitter doing what's that called? The Periscope on Twitter, and that was a slight bit awkward one because they don't Periscope don't have their the troll monitoring moderation. Thank you, moderation shit figured out. So there were some awkward comments, but now we're on Twitch and it's gonna be great. So and why I brought this up is because last summer we did one because we were oh, part 2 is gonna come out soon.
Quick question: how did you deal with the performance issue with so many nodes on the screen? What was your debugging iteration process like?
Oh, this is perfect. Yes, go.
Wait, okay, so let me try to interpret what the comment is.
Actually, this is a very Sam question. It's not a Susie question.
It sounds like a Sam question. That's okay. All right, so can people actually see the screen? People can. Great.
Yeah, so this is what they see right now.
Yeah. So let's see. So this part I cheated. This part is Canvas.
That's not cheating.
It's sort of cheating. There's 4. So there is the data set that we use for R2D3 has about 250 data points, and then this is 250 times probably 30 cells, right? Because like there's seven times like whatever, like seven. What's that? Factorial. There's 7 factorial little crossover things. So there's like I think like 4,000 nodes there.
Do you want to do any like profiling or anything? I pulled it up.
No, I don't
want to.
So the other thing is like this I wrote in 2015. I haven't touched since, so I don't remember exactly how everything works. But like, so the process I can tell you is I actually did everything naively first, which is like there's a version of this that was just like SVG, and there was 4,000 nodes, and it was just like yes. And a lot of this stuff is actually just like So Shirley brought up the performance tab, and basically it's like a lot of this is just like okay, I'm gonna move around and like make things like move, and then see how the performance is. And there's a lot of like watching. Like some of it is actually hearing the fan go, and you're just like, oh god.
My fan is going right now, but I think that's more because of OBS and Twitch than anything.
Yeah, and then you watch this, and you're just like, okay, where are the things? Where are things sad? And you can see like, okay, self time and total time, and you're just like, this part is sad. Right now, this is like, this is hard to debug because this is the live version and everything is compressed. But usually I look at it and it's just like, okay, which is the thing that gets called the most. And then so some of the iteration process is this kind of low-level code stuff, which is like, can I get rid of as many of the like extraneous calls as possible? Because like I think the first time when I wrote it, like I was re-rendering multiple times. There was some like a bunch of inefficiencies around like, okay, like how many times are you rendering each frame? And like there's a lot of unnecessary renders. And then at some point you actually get back to like, oh, okay, what is the design, right? So the original version of this.
Sappy's birthday.
Yeah, exactly. So the original version of this, actually all of these dots almost move at the same time. Where like, and the visual effects looks a lot cooler. But like here, what you'll notice is that like I've started to move groups of them at a time. So like the blue ones and the green ones and the blue ones and the green ones and the blue ones and the green ones. So like this staggering was done intentionally to kind of like save on performance.
Can you explain more what? Well, so actually, I like what you first said, that like you started out with SVG and then you were like, oh crap, and then you went to like something else or to Canvas, because like I feel like when I first started doing like more intensive visualizations, I always started with SVG just because like SVG was much more natural to me, and like I like at first like I just wanted to get it working before I tried to optimize for the performance. But nowadays, if I know that something has like more than 1,000 or 2,000 nodes on the screen and it needs to animate, I just go straight to Canvas. Like, do you just go straight to Canvas now, or?
No, I still usually go SVG first. So I mean, a couple of things. Hi, I don't know who that is, but you might know. So 2 things. One is like, I have now started like going straight to React, which makes a bunch of like thinking about rendering a lot easier in my mind, at least.
How so? Over like you're just saying like over like D3 dispatch events and all of that.
Yeah, exactly.
Yeah. Okay, that's fair. But that doesn't have as much to do with performance as like how to structure things, right? How to structure your code, kind of thing.
It's kind of related. So the way I think about React is just like, okay, so React is very much like, okay, here's the state, right? It's just like, oh, what is the kind of abstract, what should things look like? And then renders to a DOM, which is what things actually look like. And I can do a whole bunch of manipulation on the state to get it ready before I flush it down into the DOM. And so like, because I know that I sort of can count on React to not kind of like thrash down here. Like I do all the like weird computation stuff here,
Okay.
and like every frame,
Mhm.
like I basically render a snapshot, which
I see.
say like at least like I'm not rendering more than once per frame.
Wait, yeah, actually, I think there was the second question I had was like, you said you had a line where you said you figured out some places where you were rendering unnecessarily and you took that out. Can you elaborate on that more?
Yeah, so like let's see, how do I frame this? So like oftentimes when I'm doing animation, one of the things I'm doing is like there might be a bunch of things that's affecting how I want the animation to look,
Mhm.
and it can like, if I were to just do it naively, then I would like recompute stuff every time something changes,
Okay,
and then like I would render every time something changes, which can happen much faster.
because of the scrolling.
Yeah, exactly. Scrolling is one of those cases where like the scroll event like can trigger much faster
Than the... Oh, wait, okay. So let's put it a little bit more in context first. And then we have a few more questions about React. But can you put it in context first? So because when you do the animations, you use request animation frame.
That's right.
And do I remember correctly that that's 60 FPS?
Yes.
And then so I think the part that I'm not
roughly anyway.
Okay, the part that I'm not too clear on is like, for some reason in my head, I always thought you were using, because I'm still not that great with how the request animation
works.
But like, I thought you were using that to help you with the scroll animations. That was like the same thing that you were basically doing.
Sort of.
Okay.
So think about things this way. So the way I think about request animation frame is like, for people who like play music. I don't actually play music, but like this is a good metaphor that I use. It's like the metronome. It's just like tick tock, tick tock, tick tock, and like it's a regular frame. It doesn't like it. It's basically the rhythm for rendering.
Okay.
And the way I think about it is just like, if I need something to have a particular pace and not go too fast and iterate too many times, I use that as the way to kind of rate limit how often things are happening.
Okay.
Right? And so like, for example, right, like you can imagine getting really, really precise with this animation. And like every time we scroll, it updates stuff. But the scroll event fires much more often than request animation frame does.
So the scroll event can fire when the metronome is like in between the two.
Yeah, exactly. It's like between one tick, it could have fired 5 times.
Okay.
Right? And so like one way that I use this kind of metronome idea is just like, I basically only sample or like check what the current scroll position is once per tick.
Oh, okay.
Right?
Okay.
So then like I'm basically like not reacting to every scroll event, but only like going to look at what the current scroll is every time it goes tick.
I see. Oh, fascinating. Okay. So I don't actually know. So these days before when I use so recently I've been using like third party. I think I use like Graph Scroll by Adam Pierce. And before that, I did I did my own just like scroll-based, event-based like scroller. And so I guess that's why I never quite understood what you meant when you said you use request animation frame. You're saying that you don't ever bind the window scroll event. Is that way? Like you don't bind the window scroll event. You just when the user loads the page, you just get a request animation frame going.
Sort of. It's a real rabbit hole.
So Matt says, damn, that's smart.
Yeah, it's a real rabbit hole. So what I've started using, I think this actually is thanks to like Sam and a bunch of his colleagues. Like the folks on the Google team, like I've and then also like RxJS people. What is that guy's name? David Piano. That's not his last name, but that's how
yeah.
David, what's his name?
I just know him as
it's
Piano
Dave Piano.
Guy.
Yeah, Piano dude. he wrote this really great blog post about how to think about animations using. That's probably not the best way to find it.
Wait, no. But I know his Twitter.
Yeah, so he wrote this really great blog post about like using RxJS and animation, and basically doing like reactive animation stuff. And a lot of my current way of thinking about things is based on that. David K. There we go. This guy. Yeah,
that took an embarrassingly long time.
He's awesome.
But now that we've found him, how do we find the paper you're talking about?
We'll link to it.
Okay.
I mean, it's fine. Okay. But like the idea is just like, okay, so let's see. What were we talking about? We were talking about the scroll thing.
Mm-hmm.
So one thing that I'm doing is I'm using the observable, which is the idea of like basically it's like a.
You have a keyboard here.
Oh, I have a keyboard here. Yes, thank you.
That's your keyboard that you set up.
Yes, that is true. Throttle. Operator. Blah blah blah. That's not right. So I think it's called throttle time.
Wait, while you're doing that, I'm going to read some of the comments. So let's see. Would you recommend learning React for Wiz? What are the big benefits? Let's come back to that. I love me some React. I like hearing. So Jen says, I like hearing why others choose React for their projects, especially for data viz. And Jen also says, request animation frame sounds incredible for those updates, the scroll updates. I'll definitely have to look that up. Jerry Moore says, surely the viz you worked on with homeless people busing around the US is great. Kudos. Thank you so much. That was me and Nadi, and it was a great project. And Jen says, thank you for asking all my questions for me, Shirley. Of course. Lee Rad, the finite state machine guy. Is that you?
That's David.
No, that's David. Okay.
So if I were to start part 2 all over again, the way I would structure it is using something like this. So this is RxJS throttle time. So imagine this is a stream that you get from the scroll event.
Okay.
Right? So like this is like 3 milliseconds, 5 milliseconds, whatever, right? It's just like a bunch of these things firing at once.
Okay.
What throttle time does is like it will pick a value from this stream at most 50 milliseconds.
Is this the same?
At least 50 milliseconds apart. Yeah, I think that's right.
Yes. Yeah, so this is similar to how Lodash implements their dot throttle, right?
Yeah, basically.
Okay.
Basically, but then like the reason why I like observables is that like you can it's of an object you can pass around.
Okay.
So then like I create this thing once in the kind of whole setup, and then like this is a thing that gets passed into multiple components.
Okay.
So like what do I mean by components? Imagine part 1 is not done this way, but imagine each one of these like sections is a component, and they can all share the same object.
So by sections, you mean the visualization is a section?
Yeah, so like this thing, so when it locks in and it sticks to the screen, that's one section. Right?
Wait, so the histograms are one component.
No, this whole thing is one component.
The whole visualization is one component.
Yeah, so
okay.
histogram is like subcomponents underneath it. Right?
Got it. Okay, so there's the like root that has the visualization and the text on the side.
Yeah.
And then the visualization then has sub-visualization components that I'm guessing, like, depending on where you are in the page, it chooses which sub-component to render.
Yeah. Well,
Roughly.
Yeah. So then, like, what something like this allows me to do is to then say, okay, well, I'm really only going to recompute all of the things at most once every
50 milliseconds, or
or like 16 milliseconds, which is the frame rate.
Wait, and when you say recompute all of the things, you mean from the root level? This is going on at the root level. I'm just trying to figure out the structure of your code.
Yeah. So it's like at the root level.
Okay.
Right. Because like this object, this observable is triggering. Basically, it's triggering everything else. It's telling everything else, okay, here's the current scroll position. Do with that what you will.
Okay.
And all the components then says, okay, well, the scroll position currently is 321. what does that mean for me?
I see. And so some of them will be like, well, I'm not important at 321, so I'm gonna
They were just like, exactly. It's just like, so if you imagine like, whoops, this particular animation, like way above, it's not even relevant. So then it takes that number and says, okay, it's not in my section yet. I'm just gonna not worry about it.
Okay. Can you so Part 2 uses observables in RxJS?
So Part 2 uses RxJS. Part 2 uses React. There's some WebGL in there.
Oh, cool! I didn't know that.
Yeah. So Part 2 has like there's one component of Part 2 is like there's like a lot of particles that move around and it is choreographed differently.
Oh, it was beautiful. But I got to see it to give feedback, and it was beautiful. And I was hoping that it would be out by now, so we can share it. I mean, that's all right because Data Sketches is not done. We're
not actually having a contest on who can be later. No, that's not what we're doing.
No, we were. I forced a bet on you. That's like whoever finishes first, the other person has to treat them to lunch or something like that.
Yeah.
And right now we're still tied. Both horrible.
It's terrible.
Okay, wait. Going back to actual things. Okay. So I want to go back to because in that case I'm still a little bit confused because observables is basically what you're monitoring the scroll event with because you're throttling and you're monitoring the scroll event. Can you tell me? So you said the observables are great because you're monitoring it, and then the data can be like passed down to all of the components. But like, what's the data other than just the scroll position? Like you said something about like how the observable.
A bunch of things. Yeah,
okay.
There's a bunch of things. So some of the other ones that like I have root level kind of observables for are like screen size.
Oh, okay.
Because like a lot of graphics they're not like really responsive, but they're sort of responsive.
Okay.
They're responsive insofar as they responded to like they try to fill up the space that the browser window has. And so then like every time the window size changes, it tries to update. It doesn't work super well.
Okay.
But anyway.
Oh, I didn't test that for you.
No.
Okay.
It's okay. And then there are other things that are like there's some animations that are at least in Part 2 that are not strictly scroll based.
Okay.
Some of them are like timing based.
Okay.
So it's just like for example, like you scroll into a section and like there is an animation that like is supposed to take a second after that event happens.
Okay.
Right?
And why is that? Just to like...
It's just like different, like just make...
Pacing?
Just pacing kind of issues.
Okay.
It's just like, oh, when does the label come in? Or
I see.
Or like when things kind of like fade in and fade out.
Have you considered just using GreenSock for all of these timing things?
No.
Okay. Is that just like... Well, I mean, like, it depends on how, like, straightforward the timing things are. Like, because a lot of your things are scroll-based. So, actually, even with scroll-based things, it's kind of nice with GreenSock. Although, I think the difference might be that because you have some things that are scroll-based and some things that are timing-based.
It's like, definitely a mix.
Yeah, but, like, I would say GreenSock is worth it if you have things that are coming in at different times that are like becoming unruly to manage with just D3. I think that's when it becomes
so that's the thing though, right? Like what I've talked to Sarah about this a little bit, but like my I think the part of my brain that's like what's going to do that has basically figured out how to do that with Rx.
Ah, got it. Okay.
So Rx basically deals with all of my timing and delays and stuff.
Okay.
And Rx actually has a ton of like cool methods for dealing with stuff like that.
Yeah, I want to look into Rx.
Yeah, Rx has like changed how I think about like animation programming.
Oh, that's cool.
It's kind of crazy.
Wait, have you talked to like? Is there any sort of like a Rx versus like? Well, I guess have you talked to anybody about like GreenSock versus?
No, that I have not.
Okay.
Yeah, there's a lot of like this stuff is like distinct until change is really useful. So basically it's like, so you know how like, oh, okay, like the scroll position, one thing you could do So you have asynchronous events that don't come in with a frame tag and you kind of synchronize them. That sounds very useful.
Wait.
Yeah, that's effectively what's going on.
Wait, say that louder. I don't know if that got
So the
picked up.
comment says, so you have asynchronous events that don't come in with a frame tick, and you can kind of synchronize them. That sounds very useful. That's exactly what I'm doing with Rx, basically. Right? Like, how do I get them to kind of come in at this regular interval? And the distinct until change is then layer on top of that. If I don't want to, so like React animation frame, right? Not request animation frame. Like it's going to be a steady stream of things every frame. But you can actually use distinct until change to say, okay, well, don't tell me unless the actual value changes. So then like you save even more. You save even more performance / like computation.
I see. So let me try and recap my understanding. So you use observables to kind of sync the scroll events with your request animation frame because, like, if I think about it, it's kind of like the person comes in and they start scrolling, and that scroll will trigger some animation with the request animation frame. And as that request animation frame is going, they might have scrolled into a new section that needs to animate differently.
Right.
And so that's why like they're going at the same time, but like you're trying to sync up like this with how often you check into this.
Yep.
Okay, I think that makes a lot more sense now. So that's why you're still using both. You can't just like be running. I mean, you could, I guess, but like
you sort of could. I mean, like if I were to restructure, like if I were to start a new project today, like I would try to think about all of the event-driven stuff from using like basically like streams of observables and like different combinations of them, because like there's a lot of cool ways you can combine stuff.
And this is really cool because this is a completely different way of thinking from like say like how Graph Scroll was implemented, or I want to try out Scroll Llama from
this
Pudding.
This is
from
Russell.
Russell from the Pudding, and I thought this looked really cool. But this is still a very much a scroll based and like scroll event based implementation, I think.
I haven't looked into it, so I don't know, to be honest. Like some of the new stuff that's in here is like intersection events. So like when something comes in and out.
Yeah, I think it
so
says.
The layer is that you only
Where
have
does
to
it say?
render the view and it's dirty. Yeah, basically. So.
Oh wait, yeah. Intersection observer.
Yeah.
What's the difference between that and observables?
Intersection observer is like an actual browser API.
Ah.
So like you can subscribe to it. So like you can turn it into observable if you wanted to. But the idea is just like, oh, when does that section come into view versus when it comes out of view? Yeah, it's not supported in other browsers. It's pretty sad.
Wait, and then Andrew says, so that layer is so that you only have to re-render when the view is dirty.
That's effectively it. So like a lot of this stuff, I think earlier he asked the question around like game type rendering versus JavaScript animation stuff. I've basically gone all in to learn about like game animation stuff because like
you're quite inspired by game animation,
right? Because like to me, it's just like they have been performing in like they've been working in kind of like this very performance constrained environment for a long time. So all their thinking is around like how can you save on those kind of graphic calculation stuff as much as possible, and like even like React is sort of like that, right? So like React has the whole like virtual DOM and like computing the diff between DOM thing. The whole idea for that is just like how can you not paint to the screen as often and just like figure out what has actually changed. And that's like one of the reasons why I like using React to think about this stuff, because like it's yet another layer of like abstraction that helps me not have to deal with painting things at all as often.
Do you want to talk about, actually, let me read some of these. So Andrew says, if so, I guess you get the benefit of rendering at whichever rate is slower, the scroll rate or the frame rate. Cool.
Yes, that's exactly right.
These are really great comments. And then Puka says, cool stream, thank you so much. And then Matt says intersection observer is not supported in older browsers. And then Jen asked how much older, so we'll wait on that answer. Andrew says virtual DOM is essentially dirty rectangles, GL scissor.
I know what dirty rectangle is. GL scissor I don't, but like effectively, yeah, I think the gist is right.
So should we talk about React now? Because you've kind of like hinted at it, like why you prefer it for data visualization. Past what you've already said, which is that it really helps you think about it from like I think you said like calculation of state and then how often it gets pushed down to the DOM, and then that's performant because it has a virtual DOM calculating the least amount of updates. So that's one. And then is that the main reason, or?
That was the main reason why I started doing that. I'm just gonna pull this over here so people can see it. This Matt, the link that Matt just put in the chat stream. Yeah, basically iOS is sad. It doesn't work. It's okay. It's a thing that happens.
Wait, can I do a small, tiny, like unrelated rant? Which is that the other day, so I've been working on this project that I don't know if I've shared with you, but basically I like have to go through all of these like pixels in an image, and like I filter it by like a bunch of things, and then I put that into the GPU to do like make it, because I'm doing it to like 1,000 something images. So I first pushed that to the GPU, and then I was like, oh, let me do it, like let me now put that into a web worker so that not only am I using the GPU, but then like it's in the background. And then I realized that web workers don't support like most of, like except for I think Firefox, it doesn't support GPU operations.
You're trying to do that in the browser?
Oh yeah, so it's like live. Let me just show you what I did.
Jeez.
Oh yeah, it's
that
just like what it is. I'm just like, why am I doing this to myself? I have no idea, but I'm a masochist.
Noodle.
So basically, I can like filter by hue, saturation, and lightness. And basically, this is gonna take a little bit because I've now ported this into the into web worker. But did you see how long that took? And then it's gonna take a little bit for it to like come back. Yeah, no, yeah. Do you see how like a lot of, so this is now like it's everything is grayscale except for the things that fall under like that hue that I
that you selected,
that I filtered by. Yeah, so I first put this into the GPU and it was great, and then I put it into the web worker and then it didn't. I'm like, what?
Wait, so why doesn't it work with web worker?
Apparently it's just not support GPU.
So is it okay? So the way my understanding of how the web worker thing works is like there's a main thread for like how your normal JavaScript stuff is running, and a web worker is basically send work to another thread.
Yeah.
And then like that guy, that thread is basically responsible for like, okay, I'm done now. I'm gonna send it back.
Yeah.
Right. Because that's actually in part 2. There's a good chunk of it that where the particles are controlled by a force layout, and like I have the force layout running in a web worker.
Yeah, so I think a lot of that work, like a lot of I think the most basic JavaScript functionality works, but like
so like, I'm guessing the web worker thread can't speak to the GPU.
Yeah, not yet. It seems like so. This is interesting. So somebody, when I was doing this live stream, somebody sent this over to me, and I thought it was super useful. So this is like all of the different browsers, and here's all the functionality. So you can see like. I thought it was really cool, but like, for example, you can read files into the web worker, so you don't even have to like, read in like a JSON file in the main thread to send over. You can like read it in on the web worker thread, except it's only working in, this is the Firefox column, and this is, I think, IE, Chrome, Safari. Oh, and then you can see like, I wanted to do image data because that's how I'm doing the, like getting the pixel data, and it's not supported anywhere but Firefox.
No, that sounds about right.
And then there's like WebGL and off-screen canvas, which is really great too, but it's not.
Once again, no support.
Yeah, so okay. I was sad. I was sad faced. So I don't know. I think I'm just gonna put in like a
I don't know how you're gonna do this because like this is a lot of computation to do in the browser.
So I'm gonna. Well, first of all, there's like 30 music videos in here, and I think I'm just gonna like pare it down to 5 to 10 at a time. And then second of all, it's gonna be collapsed. like these images are going to be collapsed until you fisheye hover over them. So then like I think I can do like optimizations of how like I load them in.
No, but isn't that you still have to compute like which frames have which colors, right?
Yeah. But like I also that's okay because I actually have data saved of which frames have which colors.
Oh, okay. So you pre-compute that. That makes sense. Okay.
That's already pre-computed, but like it just the thing that takes a long time is going through all of the pixels in the images and grayscaling them. Yeah.
Oh, so you're not gonna get away with that.
No. But that's okay because it will be collapsed and then I mean, it's just that, like, background computation, the computer might... A person's computer might cry. So I might even just be like, this is only supported if you have a...
Yeah, this is like how I feel about RGD3. Like, people keep asking me, it's like, hey, this doesn't work in mobile. I'm just like, no, nope, it doesn't.
And it kind of really sucks.
And it's almost like sorry, not sorry. Because it's like...
It's like this balance of like I want as many people to be able to see it, but I also want to like try out the newest technology that like so I mean yeah
that's how I feel. I'm just like no, that's not how I feel because like I always feel like okay, RTD3 is just like it's a personal project. It's almost like an art project.
It's almost an art project.
It almost is. It's just like it's an art project. I get to choose what canvas I want, and I want a canvas that's at least this big.
Okay.
I'm just like, I don't work for the New York Times. I don't work for the Guardian. I don't need to make this thing work on my phone.
Oh my god. Yeah, okay. So the Guardian project, wait, I told you. Yeah, I told you at the end, trying to make it work for all devices and like how it degrades was like, I was near tears.
Yeah. That is an impressive amount of patience.
I think, yeah, that's why I took like a week off after...
Wait, Andrew says, seems like you can do something really fast with fragment shader. That probably is true, but then you'd have to learn how to write fragment shader.
Which I've been wanting to... Oh, yeah. Okay, so I've been wanting to learn anyways, but then I don't know... Like, because my understanding is if I use a fragment shader, that's still going to be on the main thread, and that's still, like, like going through all of those images... No,
this fragment shader will be on the GPU.
Okay.
Yeah.
Would it still? It
won't be on the web worker.
No, but will it still lock up the interactions, like the UI?
Oh, I don't know.
Yeah, that's why I wanted to put it into the web worker because I don't
want to lock the UI.
Yeah. So that's why I wanted it in the background because like I knew that like even if it's just 5 to 10 videos, each video has about 40 images, and so that's still a lot to compute through.
Yeah, that's a good question.
Oh, and then Andrew says, I don't know if we can get an HSV color space in the shader, though.
We need Sam.
Sam, where did you go? And then, wait. Oh, Philippe. It's Philippe.
Oh, yeah.
Hey, Philippe.
Hey, Philippe.
Thank you so much for joining. Wait, Firefox is... I don't know.
Well, actually, it's probably not that late.
It's plus 9 hours, I think, so that's not too bad.
That's not too bad.
Yeah, that's why I picked this time on the Sunday. You could do really fast. Jen says, so you are grayscaling everything except for the colors you've selected. Yes, that's what I was doing. And then Philippe just sent a link.
Wow.
I basically actually, so when I was porting it to the GPU, I actually wrote my own like RGB to HSV converter, which actually wasn't that hard. But I wonder if it's, yeah. This is cool. Okay, wait, we should get back on topic. That was a longer rant than
Okay, so what are we talking about now? React.
Yeah.
So I started to use React for Viz stuff because of the rendering, right? But like I've come to kind of really appreciate the component-oriented nature of React as well, because it's much easier for me to in D3, right? A lot of the primitives are like the SVG primitives, so like circles and lines and things like that, right? And like when you have to write kind of rendering code in D3 is a lot of like enter update. So enter update exit, and the update is just like you're literally composing things out of primitives the whole time. Whereas with React, what I found is that like I can actually compose things together a little bit better.
Okay.
So that like and then let these compositions of things take care of themselves. So like for example, imagine that like this thing is right like part one is in just pure D3, right? So then like I have to do. It's harder for me to kind of encapsulate a particular kind of histogram. Whereas like with this guy, I can like with React, I can. It's easier for me to say like, okay, like this is just this component and has this kind of like functional signature. And of course, like it's not really functional signature. It's like it has this prop signature, right? But once I do that, then like I feel like it's easier for me to compose things into larger pieces that are easier to wrap my head around. Whereas like with D3, oftentimes it's just like writing reusable D3 code. I feel like it's possible, but like it's not as easy for me. And then of course like part of it is because like I'm also using a ton of React at work. So then like my brain is just always like in React space. So that's kind of a big reason why I've like kind of moved towards doing a lot of this stuff in React. I still do a lot of like the geometry stuff and like color stuff using D3 functions, but like the rendering code, the way I think about the rendering code is often like most of the time now is like in React.
So one of the reasons why when I first started with React and doing visualizations in React, I still had D3 render was because the animations like wasn't as quick with React. But I think nowadays it's like what you said about using request animation frame and pushing the render updates to React. It seems like that's pretty performant now.
It's performant, but it's still hard. Like D3 makes it a lot. Like D3 takes care of a lot of the details that like React doesn't take care of for you, and so you have to like re-implement some of the like transitions. And so like some of the things. Oh, this actually loops back into what we wanted to talk about in our agenda.
We've taken 40 minutes to talk about, which is great.
Like the transitions, like a lot of it has, like I've started to like either like implement it using like React State, or using CSS.
What do you mean by React State?
So
like set state?
Yeah, set state basically.
And that's performant enough?
It's not too bad.
Huh, okay.
Or at least what I found is not too bad.
So every 16 milliseconds you set state?
Yeah.
Wow.
Yeah, I've gotten that to work. It's not great, but it works.
Huh.
It's like if you can get it to work using CSS, it's obviously better. So what I found is like, for example, like if I have a bunch of things that I need them to transition from one position to another, it's much easier to
use CSS.
Yeah, to use CSS. So like I often do what is it? So like transitions, like I use CSS transition on the translate property. Okay. Right. And then I basically in React I set the translate values. So like if you're going from x1 y1 to x2 y2, basically I have React say like, okay, set the new position or set the translate value for a particular circle or particular group of values to x2 y2, and then CSS basically deals with the transition, and that is a really nice way of like dealing with these animations. Whereas like, okay, like CSS deals with it, is on a separate thread, it's much faster. Sometimes that doesn't work, and then you have to do like, especially if you have like a custom interpolation, then it doesn't work. But like a lot of times if it's like straightforward transition, that works pretty well. Yeah, I am a bad man. Like it's like it works sometimes, but like it doesn't work all the time.
The rest says set state every 16 milliseconds. You're a madman.
Yeah, basically. Yeah, but there are some things that like kind of requires it. So like for example, and I don't remember exactly how I did it in the new one anymore. But like these dots, right? these dots basically follow a particular path.
This is your custom interpolation.
Yeah, exactly. So this is a custom interpolation, right? So like these dots are given a value, or at least so think about it this way. So like when one of these dots move, they basically move along one of these paths. And then when they move along one of these paths, they have to figure out, okay, I'm supposed to be 100 pixels along the path, or 200 pixels along the path, or 300 pixels along the path. And that's based on the current scroll position. And then I have to go and use, what is this called? SVG, get point at length, and ask the path, what is the current XY position? And then I go take that XY position and tell the dot, okay, where are you now? If you are 100 pixels along the path, it means you're at x1, y1, or x2, y2, or whatever. And so then like, there's no custom interpolation. So I pre-compute the path ahead of time. Yes, so I do pre-compute the path ahead of time. I compute the path based on, so I compute the path once per window resize.
Oh yeah, that makes sense.
Right, so I don't recompute the path. So like every time the window resizes, and of course the first time the window is rendered, I compute all the paths, and then on each animation tick, or like on each scroll position, for each dot that is on the screen, I go ask the path, what is the point at this length, and that's how you kind of create this animation.
I'm going to do something, which is I wonder what this looks like at 6x throttle.
Oh god, why are we doing this?
Wait, should I not do this?
Well, do it. I'm curious to see.
Wait, hold on. It's not, this is 6x. It's not horrendous. But
I'm also pretty horrendous, come on.
But I'm also scrolling pretty slowly.
So it's like a dynamic lookup table? Yeah, sort of. Like I compute so each dot has its own path. So there's like 500 of these paths that are not actually rendered on the screen. And then each frame the dot looks up looks up the path that corresponds to it, and says like, okay, well, where should I be now? And this actually was hard to re-implement in React, because like you draw the path in React, but you don't actually. What do you have to do? You have to use refs to actually get access to the actual DOM node. And so like that was tricky.
Okay.
Yeah. Anyway, there's a lot of like crazy.
I mean, like, so so this is one of my very first. Oh, thank you. Silent Work says I'm really enjoying this, and Jen says this is one of my very favorite conversations Shirley has streamed. Thank you so much. I think this is
Is this because it's really technical? Is that why?
Yeah, I think it's really fun. Yeah.
Okay.
Andrew says, this is great. I'm feeling inspired. Thanks, Tony. Yeah. It's all Tony, basically. I mean, I'm the same every single time. You're like, you guys are the changing variables. The guests are the changing variables. So yeah, this got really technical. It's really fun. So I think what I was going to say is, would you agree with the statement, which is that I think you figured out a way for yourself. Well, actually, yeah. So you figured out a way for yourself to deal with the animation. So you try to do CSS animations where you can, and for anything more custom that CSS animations would not, or transitions would not support, then you go back to request animation frame. Or do you use like D3's interpolator, like interpolates?
Basically, not at all.
So you use your own interpolations. So
I mean, like I use scale functions, right?
Yeah,
Does that count?
No, because that's not the interpolator.
Well, so that's not necessarily true, though, right? Like there are some things where like I'm hacking the scale functions to run animation stuff.
Yeah, and especially if you're doing Canvas, that's something. So if you're doing Canvas, you're just doing a lot of vanilla JavaScript code, because like React can't do anything with Canvas. D3 is like.
Although the thinking is kind of similar, though, right? Because like the way Canvas works, like you have to handle your own rendering, but it's still this idea of like, here is the platonic kind of state of the world, and then you have to figure out somehow how to flush it to the screen in terms of pixels. So like there's a sense in which it's very similar. So
Actually,
like,
yeah. I
like
think,
for example, like let's say R2, D3.
I think in
What
some
did I
ways,
call it? Holiday
holiday.
16?
Oh yeah. I don't know.
17?
17.
Okay, that's not right.
To the adjacent possible. Interesting.
So like, for example, this guy
What was the address?
is actually a subdomain because we got too lazy to try to figure out how to like get the main thing to render. So this is basically all canvas, but like the idea is the same, right? It's just like, oh, okay, like,
Oh, I remember I inspect elemented this.
yeah. So like all the branches and all the leaves are like canvas, but like the data structure is still, it's not React. It's done in a very React-esque way. It's just like, oh, okay, like what is the current state of the leaves? What is the current state of the paths? How do I just flush it how do I flush it on the canvas? Right? So I structure things in a very React-esque way.
But in terms of the animations, these are all custom, like you have to write your own custom interpolators.
Yeah, in a way, yes.
Yeah, because
so
you
like,
can't do CSS transitions or
yeah,
anything.
exactly. So like the dots are SVG, but the initial animation where like the paths are being drawn, like I'm literally like, okay, like wipe the canvas, redraw the path with this length. Wipe the canvas, redraw the path with like this length plus 1.
Oh, why do you... Oh, because...
Because it's canvas.
Yeah, but like, it's not... So why wipe in between? Because
or else it would just layer over, right? Because canvas, you can just keep drawing on a canvas.
Yeah, but then like, isn't it basically, it's still just growing the same exact branch. Like...
No, but then like, there's like, the branches have opacity.
So
if I keep
yeah,
painting over
sense.
them, they get really dark.
Okay, and well, actually, hold on. Let me go back to what I was trying to say was like you figured out something that works, which is CSS animations and then custom interpolators. But then I wonder for the CSS animations part, if your life would be, I'm going to go back to the green socks thing. If your life would be easier with the green sock, because green sock basically, for most things, favors CSS animation and does all the like cross-platform and all this stuff.
It seems possible. Like this part of me that's just like, there's a meta kind of trade-off, which is like how many APIs do I want to learn.
That's true, and I have yet to figure out, because I haven't used GreenSock all that much. I have yet to figure out a elegant way of combining GreenSock and React. So there's also that. But like, as someone that doesn't want to, I don't know, I have a thing where I'm just scared of CSS. So.
Yeah.
Oh, hey, Sean! Sean says React and D3 and web workers.
Yeah, there's some of that in part 2.
Yeah?
Yeah, anyway, so like, this is like another Facebook React team person. Basically, like, he wrote Recompose, which is like, which has this one particular thing that I use, like, maybe overuse. Where is it? API docs. I can hear someone's laptop fans.
Wait, Glenn.
Oh, we should close some of these tabs. I think that would. Close tabs to the right.
Okay.
Yeah.
Whoa, I did not know that was a thing. Wait, let me also read some of these. Jen says, this can be applied to a lot of performance issues, both database and not. Wait, that was in response to which part of our conversation?
I don't remember.
I can't remember. This is what's bad about. Did someone mention Webpack by any chance? I can hear some. Oh yeah, I can hear someone's laptop fan spins up. Yeah, maybe close some of those.
No, I think that's the holiday wreath.
The holiday one must be the SVG that was rendered earlier. Yeah, it's probably also Twitch and OBS triggering the fan. Yeah.
Anyway, so component from string. This is the thing that allowed me to like make RxJS and React work together really well.
Okay.
Because basically just like, okay, so I talked about how using RxJS you can create an observable of the minimum number of changes to your current scope position, right? So then like when it scrolls, it keeps updates. Basically, this allows you to say, okay, I'm going to combine that observable with a component that takes that as a prop. And so then like you don't have to deal with state. Like every time your observable changes, the React component that you get from stream just basically says, okay, when the observable emits a new value, re-render. And like it cleans up a lot of the like glue code that you otherwise would have to write.
I see.
Because otherwise you'd have to you have to subscribe to the observable and then re-render every time like it emits. So this kind of abstracts that away.
Okay.
Response to inspiration.
Oh,
Sorry, yes.
No, I was going to say, you know what I would love for you to do with your ample amount of free time that you don't have?
Right, we were also going to talk about like building a database team.
Oh, yeah. Wait.
But anyway, no, let's not go there yet.
Just
talking about like ample amount of free time.
that you don't have. No. I just want to see, like, once you release this, what I would love to see is like, just like a bunch of, I've been thinking about this a little bit, which is, there is a service called Egghead.io. I mean, you don't have to do it with them, but like something along those lines of like, or like just a YouTube channel or something, because they do like bite-sized course videos that like all stream together into like one giant lesson or something.
Right, I've seen those.
Like, I would love to see you explain different parts of your code. Like, because what you're explaining, I would love to see the code for. Like, because like when I see the code, it like sticks better, right? Like I'm conceptually understanding it right now, but like I'm still a little bit lost because I don't see the code. I would love to see you do like some bite-sized videos, just explaining different parts of your code and how it all glues together with the amount of ample time that you don't have. But like I think people will love it because it's like it's such a great way of thinking.
I think it'll be fun. I need to find a way. Like I wish there's an easier way to like. There must be a blocks thing for like React stuff. No distracting Tony until part 2 is out.
No. This is after part 2 is out.
That's probably right.
No. I'm saying this. I said I would love to see this once this is released.
Yeah. Okay. Fine.
But like, wouldn't that'd be great? Or like, you should do a write-up for the Medium publication for data sketches that will that we still have not launched. One of those, but I would love to see the code with the concept, like the conceptual things.
Yeah, I think it probably is worth. Like, there's like actually a bunch of blog posts that are in the back of my head that I want to think about how to write. Like one is around like reusable components in React for data visualizations. Like there's a bunch of stuff that we started to develop in at Noodle, where it's just like, oh, okay, like here is a more standard way of thinking about like scales and like responsive visualizations and things like that.
You should talk to Susie and Elijah about this.
Yeah, I know. Like there's a bunch of stuff that I looked at semiotics and I was like, oh, yeah, there's a bunch of semiotic stuff that I was like, oh, okay, this is really interesting. And then I thought about I'm like thinking about how to think about composition. Anyway.
Yeah, there's a lot of things that are really great here. And especially because like I know for part 1, like it was like when you were doing part 1, you were still kind of like learning all of these. So like you say yourself that like code for that one is like all over the place, but then for part 2 you really, really thought through how to structure everything, what the best way is, and I would love to see that either written up or recorded or something like that.
Yeah, actually that could be fun. Let me think about how to do that. Part 1 was so bad.
Anyways,
part 1 is like 10,000 lines of like just ridiculous like. There's like no modules. But it's like, this is why, like, partly, like, I love React, because React's taught me the idea of, like, modules and composition.
Wait, but whose mind is blown that this is done with absolutely no modules and then basically a 10,000 line file? Like, whose mind is blown by that? Because when you first...
Like, why did I do it that way?
Because when Tony first told me that, I was like, what the fuck? Oh my god.
I'm not a software engineer.
Moving on. Let's move on because we're like really over time. I know the other thing you wanted to talk about.
Wait, we also have to talk about algebra.
Yeah.
Linear algebra.
Yeah. We can do that really quickly at the end. But we've talked about R2D3, we've talked about CSS and React animations. I know you wanted to talk very briefly, or maybe not briefly, about managing data. Or should we save that for next time?
We can save that for next time.
Okay.
I guess like one thing I would say is like, yeah, it was a lot. It was insane. It's like there's a comment that says like 10,000
plus
lines. Like, it's bad. It's really bad. Yes. So if you're a Viz engineer or UI engineer who likes to do this stuff and thinks I'm insane and can write this stuff much better, I'm looking for UI engineers for my team. Yes. So
can they do remote? I don't know if everybody's in the Bay Area.
Yeah. I think remote is up for discussion, but I think my preference is for somebody to be in the Bay Area.
Yeah.
Because speaking as a designer, it's much easier to iterate on stuff when you can
makes sense.
see incremental things on the screen and talk about it.
Wait, let's also say something else that blows my mind.
Yes.
Tony doesn't even identify himself as a UI engineer. He's a designer, and he's like, this is all so amazing. It's also something.
This is what happens when you're obsessive and you're just like, okay, I need to make this work.
Love it. Andrew says that's what Skype is for. Wait, okay, so we can talk about the managing a visualization team another time. I'm glad you got to say that you're hiring.
I'm definitely hiring. I need somebody. I have 2 UI engineers on my team. I have a designer on my team. Everybody has sort of Viz backgrounds.
Mm-hmm.
But I would love to get a UI engineering manager who can really think about architecture stuff, because I'm thinking about architecture stuff, but I'm not a software engineer, and I always feel like such an imposter. Be like, hey guys, I'm gonna ask you to build things this way because structure things this way, and I have no idea what I'm talking about.
No, I think
so. The other thing is I think I told you this is I didn't learn about how to write unit tests until 6 months ago.
I still don't think I'm. I still don't.
Wait, what?
No. I know how to write unit, but actually I didn't have to do much of it. Yeah, I didn't have to. I always got away with saying that it's hard to unit test visualizations, and I never really had to do it in my full-time job.
Well, so it is hard to unit test visualizations. I actually so the. This is gonna get into nitty-gritties, but The code base that we are writing, I have lots of unit tests for the Redux side because things are, it's just hey, this is what data should go in, here's what data should come out, and it's all basic data structure stuff. Much easier to write unit tests for. Data viz, rendering things, that's much harder.
Yeah.
And I've started to play with it, but there's a ton of effort to make it work right. I've started looking at a Puppeteer and Enzyme and stuff like that to figure out how to deal with unit tests for React rendering components. Which is really hard.
We should talk about this in 6 months, a 6-month check-in, once you figured it out. Because when I was at my full-time job and we had a product that had visualizations, we definitely wrote some unit tests for the data calculation, but we never it was one of those things that always got punted. We never figured out how to do it for the rendering side. So
it's
yeah,
really hard. It's just I don't even know what you're supposed to be testing for, right? Are you supposed to be testing for the circle is in the DOM tree, right? It's
if you put canvas into that equation,
yeah, exactly, right? You're just I don't. I mean,
I suppose with canvas you could just be at this point, is it red? Or
well, so no, but supposedly you can do snapshots.
Oh,
so
yeah.
You can be hey, does this thing match this picture? But then what if the design changes?
Yeah, I mean, okay, we'll table that for the 6 months check-in.
Separate discussion.
Yeah. Hopefully in 6 months, our part 2 is released, and we can talk about part 2 and all of this.
No, so unit testing data calculation is not
hard.
The hard part.
Not the hard part.
Yeah.
The rendering.
The rendering is the hard part.
Wait, hold on. Philippe says France is in the Bay Area, isn't it? And a Peak says, agreed, I can't see myself working remote. I'm the person that will nudge their coworker if I have something in mind. Andrew says, I work so much better remote, it's crazy.
I work better remotely too. It's just, as a manager, it's harder to be a manager, managing remote people.
Did Tony just say he doesn't know what he's doing? He could have fooled me. I'm here trying to compute how he even wrote the stuff that's on the screen right now. Dobladov. Nobody knows how to write unit tests, Andrew. I can't imagine doing automated testing for anything that renders on multiple browsers. Oh my god. Image diff tests are possible, but there would be so many subtle differences. I feel like for those, it'd be like you take a screenshot and somebody actually manually looks at if it looks right or not. I feel like that's like the most straightforward way of doing it.
Yeah. I feel like there must be like, this is gonna sound completely crazy, but I feel like somebody should write like some sort of like neural network thing to like compare these images. Are they like kind of similar in the relevant ways?
We're gonna wrap this up, Tony. We're gonna
Okay,
now that you've gone into this direction, we're gonna wrap up this conversation. Let's not talk about that is out of sight the context of this.
Yes.
Dovladov says, I use Enzyme for my React tests and normally I spend more time fixing the test than writing new code. Philippe says,
that's how I feel.
Yep. Actually, that's how I felt about unit tests too. Philippe says, nobody knows what they're doing. That's the secret of how things get done.
Divs.
Ooh, what? Andrew, we use something called Ranorex at work, which does fuzzy image diffs. Wait, do you want to type that up here?
Oh, yes.
And then while that's happening, I think the last thing on our agenda is...
All right, we have something to announce, sort of.
Announce! Which is not...
it's not that big.
No, so which is that Tony and I were talking about how we want to learn linear algebra.
Yeah, we've been talking about this for a while.
Yeah.
It's embarrassing for me to like not know what linear algebra is. Stephanie always gives me hell. She's like, all this animation stuff that you do, I'm sure it's easier to do with linear algebra. I'm just like...
And on my side, like somebody at one of the conferences was like, learn linear algebra. It's one of those painful things you learn that will just keep paying off for the rest of your life. And I was like, okay, that's a great argument. And so we're going to do a Coursera class together.
It's not Coursera, I don't think.
Wait, it's not? Oh, no, it's an edX.
Yeah, edX, linear...
Yeah, no, it came up.
This guy.
Yeah. So we're going to do this.
This starts next week.
Yeah, the 21st?
Yes.
Wait,
22nd.
Hold on.
Today is the
tomorrow.
21st. Yeah.
That's tomorrow.
Yes.
Yeah.
That's what I mean.
Oh wait, no, today is the 21st.
Yes.
It starts tomorrow on the 22nd. So we're going to be watching the streams together.
Uh-huh.
Like we're watching the classes together.
And then we're going to stream ourselves doing homework.
Yeah, which I don't know if that's a good idea or
not. It may
not.
turn out to be a bad idea.
But that's okay. We'll give it a try. Mainly we're going to stream us doing the homework around the same time, 11 or 11:30 a.m. on Sundays. PST, right? PST.
Yes, that's right.
And we'll figure out logistically how to do this because we'll both be at our own places. So then, yeah. So we'll figure it out. We'll figure it out, but we have no idea what linear algebra homework looks like.
Yeah, I don't know.
So this, but yeah, if you are interested in us watching us stumbling around, or want to join to give us like help,
it's like you're doing that wrong.
Yeah, that'd be great. And actually, because like I'm not sure if it means like a lot of like notepad writing, which means like does that mean we need to like set up a webcam for like what we're writing? I have no idea. We need to look into this. But
like I'm hoping. I have no idea if this actually works. But I'm hoping it'll be like, hey, this homework that you normally have to do on paper, I'm just gonna like do it on blocks or something.
Yeah.
But I don't know if that's gonna actually work.
I don't know. We'll see.
It seems like it might not work.
Yeah.
We'll
I explained to Tony that like when I'm first learning a concept, I need to be able to write it down, and when I'm doing a math problem, I need to be able to write it down. So we'll see. But yeah, so that's what's happening for 15 weeks or however long
it's
until...
like 15 weeks, yeah.
Yeah, or however long we feel until we like feel like we're done.
We're way over our heads and need to stop.
or like we feel like... So I think for both of us, we want to do linear algebra because we want to better understand SVG transforms,
yep.
SVG filters, and then also a little bit of like... For me, like a little bit of WebGL shaders and how those work.
For me, it's also like linear algebra is like foundation for a lot of machine learning stuff.
Yeah.
Like a lot of like linear models is based on all this stuff, and I have no idea what I'm talking about. So I need to at least know. It's just like, oh right, that's the math. So that's kind of why I'm doing this.
Or I suppose like if anybody wants to watch and take the course at the same time and do the like homework with us, yeah. But I guess we'll do it until we feel like our goals are satisfied.
Yeah.
Yeah.
So like that's why I liked. That's why Stephanie found this one and it was like you should take this one. It was like one because it's visual and it connects hand calculation math and computer programming. Because if it was just math, I'll just be like I can't do this. It's too hard.
I actually love the math
I'm like a humanities major. Like I studied psych. This is not for me.
I told Tony that I was great at math in high school and it degraded in college because I studied business and I want to be good at math again. This is my primary motivation. Okay, so let's wrap up. So Andrew says Ranorex was this one, but it's not JavaScript.
It's C#.
It's C#. And then Andrew says, I know linear algebra, I just don't know how it connects to graphics. And also, thanks, Shirley, Tony, this was great. Oh, thank you. Silent Works, this was awesome. It's the first one I have watched, but will definitely be back to watch more. Thank you. Afraid Not All, this seems like a class I need to take too. Take it with us. Lyra, my interest on data visualization has been augmented greatly by just watching you two. You two are really great. Aww, thank you so much. Okay, any last words?
I'm hiring.
He's hiring.
Yes.
Thank you so much, everybody that joined. Again, I don't know. So this was Tony, and he does a visual introduction to machine learning with his partner Stephanie. And part 2 shall come out sometime this year. Be on the lookout. And thank you so much for joining. Yeah, check us out this time Sundays. From now on, except for Saturdays. Wait, no, I'm sorry, I've been announcing this wrong. Saturdays, we're doing this Saturdays.
Saturdays? This is Saturdays? Okay.
Yeah. Except for
we'll tweet out the actual times when we're actually in the stream.
Yeah. I'll do a Twitch event. But yeah, thank you so much, everybody, for joining and enjoying. Joining and enjoying.
The stream.
Yes, the stream. And see you next time. Bye bye. And this is the end. Thank you.